Hello everyone. Today we are discuss about single bus organization in computer architecture. Let's start. In this lecture, we are going to discuss a processor which has only a single internal bus as shown in figure. So there is a program counter which we know keeps the track of address of the next instruction. So this is connected to the internal bus. We have a memory address register. This is connected to the internal bus taking input from it, and also connected externally to the address bus as shown in the figure, and also connected to the externally to the address bus as shown. So next is MDR, which is memory data register. Again, it is connected to the internal bus as well as the external data bus as shown in figure. Inputs and the two outputs. So the output input 1 is connected external bus and the one input is from internal data bus. Again, output are 2. It can send the data bus and it can also send back to the internal bus. ALU, arithmetic logic unit. Here we have this ALU, and also there is a register, general purpose register. So if there are n register, so starting from R0 to R1 and up to the Rn minus 1, which is general purpose register and also connected to the internal, and there we have instructions register which are input from the internal bus and the pass it on the decoder and encoder of the logic. Instruction register have internal bus and it passes the output to the decoder, and then decoder sends the control signal. So the instruction which is currently being executed, and once this instruction has been received in the IR, then IR sends the decoder and control logic which will decode the instructions and generate appropriate output. That means control signals. You can see there are three Y, Z and temp as shown in figure. Here Y is connected to the input of a multiplexer, and the other input of a multiplexer is connected to the constant 4. Then the output of the multiplexer goes into one port of the ALU, and the other port is getting input from the internal bus of the internal bus as shown in figure. Are done in the ALU, the result is put in the Z register, and there is another temporary register. Constraint in the single bus organization is that any given time, that means any clock cycle, only one of these unit can put the data into the bus. So let's say if MDR is putting the data from the bus into onto the internal bus, so it that same clock cycle no other unit can put data onto the bus. If only if Z out is enabled, so similarly each of these units that are connected to the bus, they have these appropriate control signals which will they're taking data from the bus or putting data out onto the bus. So why do we have this constant 4 as an input in the multiplexer. In this processor, we are assuming in this system. Here, right now we have shown like R0 as being connected to the bus in a bidirectional manner. That means it can take data and can output data also. But actually there is a control signal associated with each of these unit signals. So if this register R0 control R0 in which will allows data to come from the bus into R0. R0N is not enabled. That means if it is 0, then even if data is here, it cannot go R0. Similarly, if R0 wants to put data out onto the bus, R0 out has to be enabled and then only contains the R0. So the temporary register can take data. These units are connected to the bus. They have this appropriate control signal which controls their data taking from or put the data. So why do we have this constant 4 as an input to the multiplexer, in which processor we are assuming in this system where every instructions is of 4 bytes of length and the memory is byte addressable. So if we have to increase the PC 2.2 next instruction, PC has to be incremented by 4 and the so that's constant 4 has been put over here. This selects will allows either the constant 4 or go pass through the ALU, and if it is selected Y, so the 16 adds consider ALU can perform 60 operations. Let's say ALU can perform 60 operations like add or not subtract. 60 operations can be controlled by either 16 control lines or one of each operation we can encode. These have 4 control lines as shown lines. In that case, each combination of these 4 control, so these control signals, it is the output